Chapter 5, Section 7. Systems of linear inequalities. What did we talk about last week in 5.6? What? Nope. Inequalities. What do we do with inequalities? Yeah. We graphed our linear inequalities that had two variables, right?
Yeah.
We graphed them very similarly to our equations. We used our slope. We used our y-intercept. Intercept to get our boundary line. How did we determine if it was a solid line or a dashed line?
If it had a line under the sign.
What did we do if it had a line under it?
If it had a line, it would be a solid line.
Very good. If we had a line underneath our inequality symbol, it was a solid line. If there was no line, it was a dashed line, right? And then how did we shade?
We shaded on the other side of the line.
Yeah, how do we decide which side of the line to shade though? Greater than or less than, right? If it's in slope-intercept form and its y is greater than, would I be shading above or below the line? Above. If its y is less than, below. We all good with that? So we're going to have to do that a lot more today. We're going to be solving systems of linear inequalities. Okay? So let's get started. A system of linear inequalities is a set of two or more linear inequalities in the same variables. An example is shown below. So right here's an example. That's a system of linear inequalities. So just like our systems of equations, we have two inequalities that form my system. A solution of a system of linear inequalities in two variables is an ordered pair that is a solution of each inequality in the system. So do you remember with our systems of equations, for an ordered pair to be a solution, it had to make both equations true, right?
Yeah.
Same thing here. For an ordered pair to be a solution, it has to make both inequalities true at the same time. Just because it's a solution of one inequality but not the other, that would mean that that ordered pair is not a solution of my system as a whole. Does that make sense for our solutions of our systems?
Yeah.
Okay. Is anyone writing this down or can I move on?
We can move on.
Okay, I'll give you a little more time. Go ahead and move on. Make sure we're quiet, please.
Can I get a tissue, please?
So, example 1. Tell whether each ordered pair is a solution of the system of linear inequalities. So here's our system of inequalities. Y is less than 2x. Y is greater than or equal to x plus 1. And it gives us two ordered pairs. So let's start with letter A. 3, 5. How am I checking to see if this is a solution of my system?
You gotta plug in.
Plug the x value into x and the y value.
Very good. What's my x value?
3.
3. My y value? 5. So like she said, replacing my x value with x, my y value with y, working down both sides of the inequality. So y is less than 2x. What's y? 5. It's less than 2 times x. What's x? 3. And now I'm just working down both sides of the inequality. 5's already worked out for me.
Mm-hmm.
What? And then I have less than. And then what's 2 times 3?
9.
6. Thank you.
What? Oh.
Okay. Once I work down both sides of my inequality, I look at the statement that's left over. 5 is less than 6. Is that true or false?
True.
True. So it checks out for my first inequality. We okay with that? But just because it's a solution of my first one, does that mean it's a solution of the whole system?
No.
No. I've got to check the other one as well. So once again, what's my y value?
5.
5 is greater than or equal to. What's my x value?
3.
3 plus 1. Working down both sides. What's 3 plus 1?
4.
4. So my statement is 5 is greater than or equal to 4. Is that true or false? True. Remember, with greater than or equal to, it's got to meet one of those conditions for it to be true. It's either got to be greater than or it's got to be equal to. So since 5 is greater than 4, 5 is greater than or equal to 4.
Yes, sir.
So that's a true statement. Checks out for both of them. So what can I deem true about this this ordered pair? It's a solution. So I'd say 3, 5 is a solution.
Or can we just say 3,5 solution?
I don't think two little words like that are going to hurt you.
E solution.
3, 5 is a solution. Questions on letter A? You okay with that? Can I erase and move to B? Letter B. Plugging in X and Y. The X and Y values for X and Y. What's my Y value?
0.
0. Greater than or equal to. What's my X value?
-2.
-2. I guess I started out with the second one, didn't I?
Yeah.
I don't know why I did that, but oh well.
Oh well.
You can do it this way still.
We got it.
0 greater than or equal to. What's -2 plus 1?
-1.
-1. 0 is greater than or equal to 1. Is that true or false?
False.
It's true.
True.
0 is greater than -1. So it works for my second inequality. Right?
Yeah.
Let's check the first one. What's my Y value?
0.
0 is less than 2 times X. What's X?
2. -2.
-2. 0 is less than. What's 2 times -2?
-4.
-4. Is that true or false?
False.
False. 0 is not less than -4. So is -2 0 a solution?
No.
No. It's a solution of one of my inequalities, but not the system as a whole.
So it got to be solution to both of them to be a solution.
To the system. Yep.
For real.
Okay, so on the other one, it would be, it is a solution?
Yep. Letter A, 3, 5 is a solution. -2 0 is not a
You
solution.
got to plug them into both to see if it's really a solution.
Yep. Now, if I would have done this in the order that the inequalities appear, let's say I did 0 or Y is less than 2X first, we would have gotten this, right?
Mm-hmm.
Would I have had to do the second one after that point?
No.
No, because it already doesn't fit for the first one, so I already know it's not a solution.
Right.
I just accidentally went backwards there. My bad.
Right.
Are there any questions on example 1?
No.
Can I move on?
Yes.
Okay, the graph of a system of linear inequalities is the graph of all the solutions of the system. So when I have a solution to my system of inequalities, I'm going to have an infinite number of solutions. That's why we use a graph to represent those solutions. Okay?
Yes. Your neck hurt?
Hmm?
Your neck hurt?
No, I was just stretching it.
Okay. That's healthy. I think.
Move on to my next example. Okay, a little more time.
I have more than one page to do today.
What do you mean?
Is it 2 pages in a row?
Moving on. Here's our steps to graphing a system of linear inequalities. Step 1, graph each inequality in the same coordinate plane. Step 2, find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. So back in chapter 5, section 1, how did we solve systems of equations by graphing? Nope, we didn't do any shading in 5.1. Yeah, I graphed the two lines on the same graph, and wherever the two lines intersected, that was my solution, right?
Yes.
Okay, so kind of the same concept here, a little bit different though. We have shading with our inequalities, right? So I'm not looking for the intersection of the two lines, I'm looking for the intersection of the two shaded regions. So let's look at this example real quick. They have y is less than x plus 2. Well, what's my y-intercept there?
Negative 1.
+2?
My y-intercept?
Oh.
The number without the variable.
Constant.
My constant, what's my constant? 2. So they put a point at 2 on the y-axis. What's my slope? The number times x?
1.
1. So 1 over 1, up 1, right 1. Down 1, left 1. That's how they got the points for that boundary line. Is there a line underneath this inequality symbol? No, so that's why it's a dashed line. And then it's y is less than x plus 2. So would I be shading above or below that line?
Below.
Below. So that's why this area over here is blue. That's how they got the graph of that inequality. Any questions about that?
So it would be shaded on the blue side?
Yeah. That, the blue line shaded this way. Yep.
Okay. So are you just shading in between the two lines?
Hold on. We're going to get there. Okay.
Me.
This red one. What's the y-intercept? -1. So there's a point at -1 on the y-axis. What's my slope?
2/1.
2/1. Up 2. Right 1. Down 2. Left 1. Line or no line?
Line.
So is that solid or dashed?
Solid.
That's why it's a solid line. Y is greater than or equal to 2x minus 1. Would that be above or below my line?
Above.
Above. That's why this region is red. Does everyone see how they got the two graphs of each inequality?
Yeah.
Okay, so like it says here, it says find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. So this half is red, this half is blue. Does everyone see where they're overlapping? It's kind of a purplish color.
Yes.
That, in that region, is the solution of my system of inequalities. Yes?
What about that part that isn't shaded?
Up here?
Yeah.
That just doesn't get shaded. That's not part of my solution. The only ordered pairs that are a part of my solution of my system is this specific shaded region that's purple.
So
Not the red, not the blue. Those are solutions of those individual inequalities by themselves. But we're looking at it as a system as a whole. So I'm looking for the overlap of those shaded regions, which is right in here.
So if it's anything outside of it, it would be not a shaded.
Yep. So 2, 0 is not a solution to my system. It's a solution of this blue inequality, but not as of the system as a whole.
So how about -1,
-1, 1. That's on that blue line, right?
Yeah.
But it's a dashed line. What does the dashed line mean for those ordered pairs? It's not a solution.
They had what? Oh. Okay.
Okay? Now, this ordered pair up here, that would be 3, 7. That's on the solid line, right?
Yeah.
But is that a boundary for my actual solution? No, so that would not be a solution either. Now, 1, 1 would be a solution because it's on the solid line that's boundarying. I don't think that's a word. Boundarying is a boundary for
It's a word now.
this section. Okay?
I like that word.
I feel like it would have been easier to understand if it was actually gone through before, like if it was made,
Say that again.
like instead of just showing us the full.
Oh, we're about to do some examples that we're going to go walk through step by step. Okay? But does that make sense that the overlap of the shaded areas is my solution?
Yes.
Now, am I going to expect you to carry a red pen and a blue pen with you and use 2 separate colors every time?
No.
No. You're just probably going to use pencil lead, right?
Right.
So, do you think it'd be very easy to tell where the overlap is if it's all shaded in pencil?
Yes.
No, it probably wouldn't be very easy. It's doable. Just probably wouldn't be very easy. So I'm going to show you how I like to do it, especially when I'm using pencil. Would someone have their hand up and have a question? Okay.
Oh, I did, but it was about this. We are going to do it.
Okay. So let's look at an example where we're starting from the beginning. No. Graph the system of linear inequalities. Y is less than or equal to 3. And y is greater than x plus 2. So what we're going to do first is we're going to graph both of our boundary lines first. Okay? So y is less than or equal to 3. How do I graph that?
You go.
Y will be at 0.
No. I like your thinking, but it's... Say it again. This is hoy, right? Because it's y and a number. Right? Don't forget about hoy and vux. Those are still in play. This is hoy, it's y and a number. So which axis is it crossing if it's hoy?
The horizontal line.
Which axis is it crossing?
Oh,
The y-axis. Where is it crossing the y-axis at?
3.
3. So I put a point at 3 on my y-axis. What does the H on hoy stand for?
Horizontal.
So it's a horizontal line going through that point, right?
Yes.
But I need to determine if it's a solid line or dashed line. Does it have a line underneath it or no?
Yes.
It does. So what kind of line is it?
Solid.
Solid. So I'm drawing a solid horizontal line through 3 on my y-axis.
I thought it was horizontal.
It is a horizontal line.
Oh. Okay, the horizontal go that way. Right. Oh, okay.
So there's my boundary line for my first inequality. Everyone okay graphing that?
Yeah.
Now I'm not going to shade yet. I'm going to wait and do my shading until I have both my boundary lines.
Right.
Second inequality. What's my y-intercept there?
2.
2. So I put a point at 2 on my y-axis. Y is greater than x plus 2. What's my slope there?
1, 1.
1. 1 over 1. So which 2 directions am I going?
You're going to go up 1 over 1. Right 1.
Up 1, right 1. How many points do I want you to have on your graph?
As many as you can get.
As many as you can fit.
You know.
You already know. And instead of going up 1, right 1, I can also go
Down 1, left 1.
down 1, left 1. Once again, get as many points as you can fit on that graph. Everyone okay graphing in slope-intercept form?
Yes.
And graphing Hooy-Vux.
Yes.
Is this a solid or dashed line?
Dash.
Dashed. There's no line underneath my symbol, so I know it's going to be dashed. There's my 2 boundary lines. We okay with that?
Yes.
Okay. Does everyone see that our 2 boundary lines break our graph up into 4 sections?
Yes.
One here, one here, one here, there's one here. Everyone see those 4 sections?
Yeah.
Okay. Now we're going to get into the shading part of it. Because like I said, it's going to be difficult to see what our actual solution is if it's all shaded in one color. Right? So I'm going to use an elimination process where I eliminate sections that I know will not be shaded. Okay? So y is less than or equal to 3. That's this line right here, correct? If it's y is less than 3, would that be above or below my line that I'm shading?
Below.
Below. So would any of these sections above that line be shaded?
No.
No. So what I'm going to do is I'm going to put an X through those sections, saying I am not shading those. Okay? Now I've got to look at the second inequality. Y is greater than x plus 2. That's this line right here. If it's greater than, y is greater than x plus 2, would I be shading above that line or below it?
Above.
Above. So would I be shading anything below that line?
No.
No, so I'm eliminating those 2 sections as well. Do I have 1 section left?
Yes.
Yeah, I do. This is my solution.
Why wouldn't you just shade the one that you know? You already know they're intersecting. Like,
Say that again.
you already know like what your section is.
We didn't know what it was before. Before we eliminated those 3.
Oh, so it's not always just the one on the left, like the one.
No, it's not always bottom left. It could be top right, top left. That's why I got to use kind of this method to determine which section it's going to be.
Okay.
Now, if I were to use 2 different colors here, this whole section would be shaded in one color. This whole section would be shaded in the other color. So the overlap would be right there where we shaded. Does that make sense?
So you don't have to shade into 2 sections? So,
Nope. We just want the one that's a solution of my system. So the overlap of where those 2 shaded would be.
So if it looks like a triangle or something?
Yeah, they'll all kind of look like triangles. Kind of.
How would you find the points? Because, like, I was thinking like -3, like 1, but you have to go on the y-axis first, right?
So that shaded region is representing all the solutions in my system of inequalities. So if an ordered pair is in this shaded region, it's a solution. So -3, 1 is a solution because it's in that shaded region. Now, 3, 1 is not a solution. Okay? -3, +3 is a solution because it's on a solid line bounding my shaded region.
Right.
There we go. I'm going to start using that word now. Now, -2, 0 is not a solution because it's on a dashed line bounding that shaded region. Okay? Does that make sense?
It's on a dash line.
That is a dashed line.
You need to make a definition for boundary.
Boundary.
And then put it in Oxford Dictionary.
Yeah, I need to do that. That'd be pretty cool.
At least Urban Dictionary.
I don't understand what you just said.
Just
What's your
add it
question?
to the end.
Huh?
What's your question?
Cause how is the -2 not on there?
Negative 2 comma 0?
Oh no, like -2 like almost 3.
Negative 2, 3 is a solution. It's on a solid line boundaring that shaded region. Now, 3, 0, or 3, 3 is not a solution because is this solid line boundering that shaded region?
No.
No.
I guess you could say bordering.
Oh, there we go.
If it's on 1, 3, what would it be?
1, 3.
Where it intersects both?
Yeah.
It's a great question. You know how you can test it out?
Use it.
You can plug
You
it
can
in.
plug it in to both your inequalities, right? So let's check that out. 1 comma 3. That's a great question.
I'm pretty.
He couldn't wait for somebody to ask a question like that.
So, what am I plugging in for y in the first inequality?
3.
Does it make that inequality true?
Yeah.
Yes.
Yeah, it does. And let's say
It checks out.
3 is greater than 1 plus 2.
So is
What's 1 plus 2?
2. 3.
Is that a true or false statement?
Yes.
False.
Oh.
So it is not a solution
Oh no, it's not.
Oh yeah.
because it's on the dashed line also.
If it's not true.
Now, if these were both solid lines, then it would be a solution. But since one of them's dashed, it is not a solution.
Why? Why?
Because the ordered pairs on that line are not solutions because it's a dashed line.
So if one isn't a solution, then it isn't a solution. If it isn't a solution for one, then it's not.
Right. The ordered pair has to make both inequalities true. Questions on example 2? Can I move on to example 3?
Yes.
Is this the last example?
No, it's not.
How many examples got left?
Like at least 20. Graph the system of linear inequalities. 2x plus y is less than -1. 2x plus y is greater than 3. Are these in slope-intercept form?
No.
No. So what are we probably going to have to do first? What do we say we're going to have to do first?
Put it in slope form.
Put it in slope-intercept form. First inequality. What's my first step to get y by itself?
Subtract 2 from both sides.
Subtract 2x from both sides.
No.
Can I combine -2x and -1?
No.
No, so how would I write it?
Y is less than -1. Subtract 2x.
-1 minus 2x or -2x minus 1. When I'm solving inequalities, what do I have to be careful about?
You gotta switch. Oh. You gotta make sure you gotta make sure you look at the. You got.
Shh, shh, shh. Yes.
If you're multiplying or dividing by negative.
Very good. What happens if I have to multiply both sides by a negative or divide both sides by a negative?
Variable switches.
You flip your inequality symbol, right? Goes from facing one way to facing the other.
Right.
Did I multiply or divide both sides by a negative here?
No.
No, so my inequality symbol stays the same.
Exactly.
We okay with that?
That's what I was saying.
Is this one now slope-intercept form?
Yes.
Yes, it is. Second inequality, what's my first step to get y by itself, William?
Subtract 2x from both sides.
Subtract 2x from both sides. Very good. Can I combine 3 and -2x?
No.
No, how would I write it?
Y is greater than -2x.
Yeah.
3 minus 2x or -2x plus 3, right? Did I multiply or divide both sides by a negative?
No.
No, so the symbol stays.
Right.
Are these both now in slope-intercept form?
Yeah.
They are. Now let's graph them. Let's graph our boundary lines first. First inequality, what's my y-intercept?
-1.
-1. Put a point at -1 on my y-axis. What's my slope?
-2/1.
-2/1, so which two directions do I go?
You're gonna go down right.
Down 2, right 1. Keep going until I can't fit any more points. What other two directions can I go?
Up to.
Up 2, left 1.
so doggone tight. You have to know.
Okay. Solid or dashed line?
Solid. Dash.
Dash. There's no line underneath my inequality symbol, is there?
No, sorry.
So that means it's not gonna get flipped.
Okay, there's my first boundary line. Now let's graph the second one. What's my y-intercept?
3.
3. Put a point at 3 on my y-axis. And once again, what's my slope here?
Negative 2 over 1.
Same thing as my first one, right?
Right.
Down 2, right 1. Thank you. And up to left 1.
Yep.
Okay. Solid or dashed line?
Dash.
Dashed. Now, when I was graphing systems of equations, and I got parallel lines like we have here, what was my answer? No solution. Because we were looking for the intersection of the two lines. They don't intersect. I got no solution. Right? For systems of inequalities, are we looking for the intersection of the two lines?
No.
We're looking for the intersection of what?
Orders. Or not.
All lines.
The shaded regions, right?
Yeah.
Where the two shaded regions overlap. So I cannot automatically put no solution here just because they're parallel lines. Because I could have some shading regions overlap here. I still got to double check it. Do I have 4 sections now or just 3? I got the one above this line, the one between the two lines, and one below that line. So I got 3 here, right? So let's look at our first inequality. Y is less than negative 1 minus 2x. That's this bottom line on our graph. If it's y is less than negative 1 minus 2x, am I shading above or below that line?
Below.
Below. So would I be shading anything above it?
No.
No, so I'm going to eliminate those 2 sections. We okay with that?
Yeah.
Now let's look at the bottom inequality. Y is greater than 3 minus 2x. This top line on my graph. If it's greater than, would I be shading above or below it?
Below. Above.
Above. So would I be shading anything below it?
No.
No. Do I have any sections available?
No.
No. So what would my answer be here?
No solution.
That impossible fourth section.
No solution. Now, let's say our symbols were flipped on each inequality. This one was shading above, and this one was shading below. My overlap would be between the 2 lines. Does that make sense? So I would have a solution there. So I can have a solution if they are parallel lines. So that's why we cannot automatically put no solution if they're parallel. I still got to check it out. Yes?
Will we have problems like this on our homework?
Yeah, you could.
Where we have solutions?
Yeah, you could.
You don't know for sure?
Are there any questions on example 3?
No.
Can I move on to my last 2?
Yeah.
Example 4. So the previous 2 problems, we were given a system and we graphed it. Here it gives us a graph and it wants us to write our system of inequalities. So I'm working backwards. Okay? So, do you guys want to start with the dashed line or the solid line?
Solid.
Dashed, I heard dashed first. Is the dashed line horizontal?
No.
No, so it's not going to be y equals some number, is it?
No.
Is it vertical? No, so it's not going to be x in some number, is it?
No.
It's going to have a slope, it's going to have a y-intercept, it's going to have y and x in it. We're writing it in slope-intercept form, so I know I'm going to have a y on the left, an x somewhere on the right, and maybe a y-intercept. Where is this line crossing the y-axis at? What's the y-intercept? 0. Do I need to put plus 0? No, so I'm just going to leave that plus 0 off. And it looks like there's a point here, 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 here. So to get from one point to the next, what's my rise over run? My slope. What'd you say? 1 over 1, or 2 over 2, or 3 over 3, which all reduce down to 1. Do I need to put a 1 in front of that x? No, it's already understood to be there, isn't it? But if it was any number other than 1, I would just put that number right in front of x being multiplied by it, right? Okay. So there's the 2 sides of my inequality. Now I just have to actually get the inequality symbol. So what kind of a line is this? Dashed. Is there going to be a line underneath my symbol or no? No, there's not. Is the shading above or below that line? Below. So is that going to be less than or greater than? Less than. There's the first inequality of my system. Everyone see how we got that? We good? Okay, second one. The solid line now. Is that a vertical line?
No.
No, so it's not x and some number. Is it a horizontal line?
Yes.
Yeah, so it's what? Hoi. Y and some number, right? What's that number? Where's that line going through the y-axis?
Negative 2.
Negative 2. So I know I've got y on the left, negative 2 on the right. Now we can get the inequality symbol. Solid or dashed line?
Solid.
Solid. So do I have a line underneath my symbol or no?
Yes.
Yes, I do. Am I shading above or below that line?
Above.
Above, so is that greater or less than?
Greater.
Greater than. Here's my system of inequalities. That's the answer. We okay with that? Not too bad? On that part at least?
I just want to know how you're supposed to do like substitution.
You don't.
You don't.
You use graphing. Questions on example 4? Last one. Same thing here, just a different problem. Do you want to start with solid or dashed?
Solid.
Solid. Is that a horizontal line? No, so it's not hoi, it's not y and some number. Is it a vertical line?
Yes.
Yeah, so it's
Fox.
vux. What and what? X and some number. Where's it going through the x-axis? 3. So x and 3. We good with that? Line or no line underneath my symbol?
Line.
Line because it's solid. Now I don't have an above and below my line, but I have a left and right, correct? So it's shading to the left. So numbers to the left of 3, would that be less than or greater than 3? Less than. There's my first inequality. We okay with that one? Okay. Dashed line here. Is that a vertical line?
No.
No. So it's not vux, it's not x and a number. Is it a horizontal line? No. So it's not hoi, it's not y and some number. So I'm going to have slope, y-intercept. I'm going to have a y value on the left-hand side. I'm going to have x on the right-hand side. What is my y-intercept? Where's the graph going through the y-axis?
Up to right 3.
What's my y-intercept?
Oh,
Negative 1. So I'm going to have a minus 1. That's my constant. It's my y-intercept. Right? Okay, I've got a point here on my graph. I've got a point here. Here. What's my rise over run to get from one point to the next?
up to right 3.
Up to right 3. So what's my slope? 2 over 3. We okay with that? Okay, solid or dashed line? Dashed, so do I have a line or no? No. Is the shading above this line or below it? Above, so greater than or less than? Greater than. Here's my system of inequalities. We good with that? Questions, comments, concerns? Get this written down real quick. I need to go through the book with you. Get it written down so I can pull the book page up. Are there any questions before I end the recording?